Logic 0, example 17.3, a set of multiple propositions. Here we have another quote from Xenophanes. The Ethiopians make their gods black and snub-nosed. The Thracians say theirs have blue eyes and red hair. Okay, so notice the parallel to oxen and horses here. And and so, again, I want to emphasize how with these variable assignments, we can see that this symbolic representation of the two sentences in the quote have the same meaning. Okay. So let's take this. Okay, so what I'm going to do is I'm going to work from the symbolic expression and just replace A with its equivalence here. So we're going to say, the Ethiopians make their gods black, and the Ethiopians make their gods snub-nosed. All right, so just following the rules of pseudo-English translation, we get this. So that's the first sentence. So notice how here we say, the Ethiopians make their gods black and snub-nosed. If we want to, treat this as conjunction here, then we need a complete sentence for that second variable. Snub nose B can't just be equal to snub nose. It needs to be a complete sentence, and it needs to actually match up with the meaning of the original. Right? In natural English, we can contract the second proposition down to just snub nose, relying on the reader to get the pattern. But if we're going to be explicit about it, this is really what Xenophanes is saying. The Ethiopians make their gods black, and the Ethiopians make their gods snub-nosed. Right? And the same thing with the second sentence. And notice here we're separating the symbolic statements with a comma so that these are two different propositions. And the second proposition then comes out very similarly. Okay, and so I think that's relatively straightforward, that this translation works. Okay, so I hope that is obvious. But why do we need B to be the Ethiopians make their gods snub-nosed? It needs to be a complete sentence. It needs to be a complete proposition. And for D as well, the Thracians say theirs have red hair. It can't just be red hair. That's not an atomic proposition. That's not a proposition at all. We need a complete sentence. So our variables always have to map to a complete sentence that describes the proposition, the statement of fact that that variable stands for. Okay. So hopefully that helps you understand a little bit of some of the more difficult aspects of pseudo English translation that we've run into in the past. And on this next exam, you'll get it a little better. And then by the final exam, I think the translation will be pretty solid. That's typically, if you're keeping up with the work and you're being diligent, then the third exam, you're going to say, okay, that's when you finally really understand the translation part. That's the most difficult aspect of introductory logic, is translating between English and symbols. Okay, it's difficult for everyone. So again, just like on the first exam, for the second exam, do your best at the translation. It's a process, and I give you, lots of partial credit. So just hang in there and do your best. Okay, and then if we're given two symbolic propositions, then our truth table will go like this. We have 4 variables. So that's not as bad as 6 variables. We're just going to have 16 rows. Whoops. And 16 rows. Now it seems downright easy in comparison to 64 rows. 1, 2. Okay. And our farthest to the right variable is just going to be true, false, alternating. And then our next variable to the left is going to be 2 trues and 2 falses, alternating. All right, next one over is going to be 4 trues and 4 falses. And then finally, we'll have 8 and 8. Okay, so there is our setup. We'll do vertical pipes all the way down. Oops. All right, and then the values of A, half are true, half are false. Sometimes students like to do this. Working back, you can just do your spaces like this, working up. I've avoided showing you that until this point, but if you want to experiment with that, that might make sense to you. And you could even do this working up. You could do these values for conjunction, which is a little foreign to me because I try to, demonstrate that going top to bottom. All right. So that might be a little bit of a time-saving device, or just maybe feel a little bit more elegant. Some students do like to do that. I don't see anything wrong with it as long as it makes sense to you. If it's confusing you, then don't do that. Let's see. And then C is 2 trues and 2 falses. And we can do that again like this. And then D is alternating, true, false, true, false. And we can do that again going up. All right. And then we just need to check with the multiple statements. Are there rows where they are both true? Are there interpretations under which they are both true? First interpretation, yes. Okay, so these statements are consistent. And just for completeness of procedure, we'll go all the way down. And we say, okay, no, they're not both true here, here, no. All right, so they're only both true under the first interpretation, but there is an interpretation under which they're both true. Therefore, the two statements are consistent. And we close off our truth table. And there you have it.